So far we have been learned about the brake system. In the brake system we design, dynamic and also thermal analysis we have discussed. Now we are going to learn about the clutch system. Prior to going to the clutch aspect, I would like to show a couple of videos how clutch works and what is the purpose of that, right. You can see that.
As a drivetrain specialist, Exidy is dedicated to the pursuit of quality and performance, as well as easy and reliable operation. The clutch is a mechanism that smoothly transmits and cuts off engine power to the transmission by engaging and disengaging. The clutch cover and flywheel always revolve together with the engine. When the clutch cover pushes the clutch disc against the flywheel, engine torque is transmitted to the transmission. When the driver steps on the clutch pedal, it releases the pressure plate that was pressing the clutch disc against the flywheel, disengaging the clutch disc. In this state, engine torque is not transmitted to the transmission. The clearance between the clutch disc and pressure plate when disengaged is approximately 1 millimeter for passenger cars and light commercial vehicles, and 1.5 millimeter for medium and heavy commercial vehicles. This engagement and disengagement is the basic principle of a manual clutch. The clutch cover's diaphragm spring is a disc-shaped spring that presses against the pressure plate and controls the amount of pressure applied. The amount of force that presses on the diaphragm spring is called the compression force. The graph that shows this change in compression force is known as the clamping load characteristic. This indicates the clutch disc's usable range. If wear exceeds this range, it will be impossible to obtain the necessary compression force and the clutch will slip. The release load of the diaphragm spring and pressure plate travel when the clutch disc is disengaged is shown by this graph, which is called the release characteristic. The other parts that comprise the clutch cover assembly are wire rings that serve as the fulcrums for operation of the diaphragm spring, strap plates that secure the pressure plate, and the clutch cover itself, which contains all of these parts. Next, looking at the clutch disc assembly, engine torque is first transmitted from the pressure plate to the facing material. This facing material is supported by the cushioning plate, which makes half-engaged clutch control possible. Engine torque is transmitted to the retaining plate and clutch plate, which hold the entire assembly together while actuating the torsion springs. The primary function of the torsion springs is to absorb fluctuations in engine revolution. Finally, engine torque is transmitted to the transmission via the splined hub.
That's about that. Gives some information about how does clutch work, and also this is the recent advancement about the clutch system, which is called a dual clutch system.
New 7-speed dual clutch transmission by ZF for sports cars. Ultimate agility. The new 7DT Sports transmission is designed for maximal sportiness and high performance. Thanks to a very good efficiency level, fuel consumption of the 7DT is partly below that of manual transmissions. Thus, it makes a considerable contribution to protecting resources. Genuine sporty car drivers.
I can see that.
The formula for more sportiness is in the detail. To this end, we have perfected the interaction between the individual components. The consequence, also all-wheel drive vehicles benefit from the new performance range of this sporty transmission.
You can see that dual clutch system. So at any given time, one clutch always engage. This is the gearbox. I think we will stop. Just the understanding of clutch is enough. Moving clutches, I would like to show the actual clutch. You can see here. Whatever you see in the video, right? The same thing you can see here. Okay. So this is actually nothing but your cover plate. Okay. The cover plate, you can see this is the diaphragm spring. Yeah. And you can see the wire which is connected with your diaphragm spring with the support plate. There is a inside the support plate. You can probably see here. Okay, see here. And another thing, this is nothing but the pressure plate. This is a pressure plate and diaphragm spring all together covered. That's why it's called cover, clutch cover. This is one part of your clutch system. Okay, and and this is nothing but clutch plate or friction plate. Okay, you have a cushioning plate inside in the middle, and both sides this nothing but friction line, where you have to have a friction so that you can make a contact. Okay, and then you have a support plate, right, which is holding the torsional spring. The springs again will vary, depends on the size of the vehicle. Capacity, as the capacitive cycle increases, the vehicle increases, the number of springs also will increase, because you want to hold the clutch, clamping. That's what you would have seen, that clamping aspect. Okay, how do I find which side is for the clutch system? Sorry, to the flywheel, which side will be for the transmission? How do you know that? Can you able to find out? One side you have a spline, the other side you have a simple thing. The spline one is the one which is going to connect with your transmission or gearbox. The other one obviously coming from flywheel. So this is the arrangement. So all together will be there, and in fact this should be other way around. Okay. So the entire thing in this arrangement will fixed after the flywheel. This is what it is. So assuming that you have an engine to flywheel, flywheel to clutch. From here, then you would expect you have a spline, through spline you get the transmission to the gearbox. This is the way it happens. So this is general, we call as a single plate clutch system. You can have multi plate also, depends on the application. In yeah. For suppose two-wheeler where the space is too small, right, you can't have this much big. So where you can have a multi-plate clutch with a smaller size. That's advantage. That's one type. The another type, you can see this is another type. Okay, this is the cover plate with the gear arrangement, and this is your clutch. Can you guess what type of clutch is it? The two springs are there, right, and you have a friction lining on the both sides, like a leading and trailing kind of arrangement, right. It's a centrifugal clutch, right. As you rotate, the spring will try to expand it, so then will make a contact through on this position, right. So this is a centrifugal thing. Yeah. So these are the, I think the weight will be very heavy. Probably you can see after the class and experience by yourself. Okay. Now we'll move on to the proper lecture aspect. So we'll spend a lot of introduction. Then we'll discuss about the two theories which we have discussed in brake system, uniform pressure theory, uniform wear theory. Those two aspects we are going to discuss. Then if time permits, we'll do a problem as well. Okay. So today learning outcomes about automobile clutch system design aspect. We'll understand clutch types, clutch working method, and also torque transmitting capacity, how the torque is transmitted during the operation. Yeah. So as I said, look at this, right? This is a diagram. You have engine, from engine to clutch, clutch to transmission, then move on to the wheel. So this is the way the power transmission occurs. You can see that is the same, the top view, engine, traction clutch, transmission, differential final drive to the wheel. Let me ask question. So what is the best position? Do you have to keep the clutch between engine and gearbox, or after the gearbox? Which is the ideal? What is the position you need to fix a clutch? Is it after the engine or after the gearbox? Just think about it. Okay. So I'll give an answer later. And what is the need of clutch? Why would you need a clutch? We have a power. Power is coming from engine. From engine to you need to go to a gearbox. You have gearbox where you can control the speeds. They are already there. But still, why would you need in between a member, a system, a subsystem, which is nothing but a clutch system? What is the reason behind? Clutch is designed with the following requirements. You can see here. So allow the vehicle to come to stop while the transmission remains in the gear. That's one thing is there. Allow the driver to smoothly take off from the dead stop. Okay, dead stop, and allow the driver to smoothly change the gears. Okay, allow the driver to smoothly. Then most importantly, must not slip under heavy loads and full engine power. That is the reason. So all the operation you need to cut the engine. Okay, because you can't have a straight away the entire power to the transmitting, right. So that would cause that severe damage to your gearbox, other transmission system, which you don't want to. So generally you will when you, the clutch purpose is you disengage the or cut the engine, right, cut the engine, right. So then you do the required changes, either to change the speed or to start the vehicle or stop the vehicle, both ways, right. So that's the purpose of clutch. So what is the difference between a clutch and brake? Are they different or the same? How? Any reason? Right. Yeah, I am sure you would know now the operation between clutch and the brake. So what is the initial condition? In clutch initial condition, you have two members, right? Driving member rotates and driven member is at rest. What is the driving member? What is the driven member in clutch? What is the driving member? What is the driven member? Yes? Driving is the engine. Okay. Driven member is the one which is going to things, that will be a rest. So then during the engagement, what happened? Both driving and driven members rotate the same speed, hence relative speed is 0, because of both are rotating the same speed, right. I am talking about your the clutch plate attached with the flywheel and the pressure plate, right. The two things are I am talking about, drive and driven kind of thing. That is the purpose. So relative speed ultimately will be 0. Brake, what do you understand brake? Again brake you have drive and driven members, both will have a. So initial condition, brake drum rotates and the brake shoe is rest, right. The brake drum only rotates, right, not the your shoe. Okay. Once your shoe made an engagement, so what happened? Vehicle stop. Okay, relative speed will be 0. right. So both members are at rest, and thus no relative speed. Okay, I mean ultimately in both as operations in clutch and brake, the relative speed is 0. Okay, in brake the entire vehicle stop, but in vehicle the vehicle keeps move on. So that's the difference, the operation of clutch and brake aspect. Yeah, you can see that this is a classification of clutch. We have under clutch, positive contact clutch, friction clutches. Then you have electromagnetic. Okay, not only electromagnetic, there are advanced versions also there. But here we are going to focus more on friction clutches. We are going to friction clutches. So under friction clutch, you have a plate clutch, cone clutch, and centrifugal clutch. If time permits, I will cover both cone and centrifugal also. In automobile, generally we use a plate clutch. Again, this you can have a single plate and a multi plate system. Okay. So in our syllabus, we are going to learn about more of a single and multi plate clutch system, particularly for automobile applications. Yeah, clutch construction you would have seen it right in the video. Now nevertheless, you can see the initial arrangement. You have a flywheel, from the flywheel to clutch disc or friction plate, both are same. Friction plate, then you have a clutch cover. So inside the clutch cover you have a pressure plate also. You have a pressure plate where that going to be facing to engagement. Then we have a release bearing. This is a bearing for operation aspect, and the corresponding clutch release bearing hub and clips. Then you have a clutch entire assembly cover. Okay. So this is a typical arrangement. So primary components we are talking about flywheel, clutch disc, pressure plate, and the throwout bearing. That is the primary components in the clutch system. Whereas secondary components are a pilot bearing, a release fork, and slave cylinder. Okay. Generally slave cylinder, when you say that, it is for hydraulic applications. The operation can be done either mechanical connections or else hydraulic or both combined. Okay, you can see this is the clutch and the pressure plate. Nice arrangement. See that earlier you have seen only the cover plate, right? Now you can see this is the how in fact maybe I can show it again. Nicely you can see this, right? So this it has to be very smooth. You can see the very smooth one. So which is the one where a friction plate going to make a contact. Okay. So this is the one is going to rubbing against your friction lining. Yeah. So these are things. So in fact the entire thing, only this portion will be contact. Only in this region is going to be contact region for frictional aspects. Okay. So you can see this is a clutch plate. Okay, yeah, and also the pressure plate also there. You can see then this is the thrust bearing, where to release and actuate for engagement, disengagement, and you can see this clutch cover. Okay, with the diaphragm setup, the same thing what you have seen here, the spring thing, right? So the moment you pressure, right, so it should either release or make a contact. So that can be done through spring actuation. So in fact the spring is nothing but you have a diaphragm type of spring. Okay, this is the one will press, right, will deflect and again release it. Yeah, so clutch cover is given. So operation of clutch, flywheel. So I am sure you know what is the purpose of flywheel. The flywheel attached to the crank shaft flange. The flywheel mass is used to store rotational energy to allow the vehicle to smoothly start out. The flywheel has machined surface which has the clutch disc rides on it, and throwout bearing, another component which is important component, exert force on the pressure plate to compress the spring and release the clutch disc. Yeah, that's a purpose having a throw by talking about the clutch plate or clutch disc release of it. Either it can be done mechanically or hydraulically operated. And again, when you talk about either you can the mechanical operation, system of levers and linkages are similar to brake system, right? Or cables connect the clutch pedal with the release fork. That's one arrangement. Otherwise, you can have a combination of hydraulic and mechanical. A hydraulic master cylinder used to transmit force to the slave cylinder, which pushes on the release fork. That's another arrangement. Depends on the vehicle size and the place arrangement. A hydraulic master cylinder used to transmit force to the slave cylinder, which is located in the bell housing and pushes directly on the throwout bearing. Mostly all the clutches are operating in the hydraulic aspect. We do not want to have a mechanical or hydraulic mechanical to avoid any failures. Okay. And again, you can see different types of pressure plates. You have a Brock, let me go back. You have Brock Beg style, and this is a diaphragm style and the long style. All our purpose is to, when now you are press the clutch pedal, engage and disengaging purpose. Okay. Let me ask question, when you are riding a vehicle, right, I am talking about geared vehicle, right. So, would you expect the clutch is engaged or disengaged position? Engaged or disengaged? Always engaged. Remember, by default clutch is always engaged. The moment you put on the pedal, clutch pedal, then only it is going to be disengaged. Okay. At any given time, the power coming from engine to flywheel, flywheel to clutch, clutch to gearbox, that is always there through constant engagement. Okay. So, when do you use the clutch? When you want to change the speed, right, or stop or start, only those three operations. Again, you can see this is a clutch which has a friction lining. This is the one, is a main function of a clutch system. Okay. You have a hub. So, the hub is again for the connecting with the gearbox, right. Torsional spring is to, as I said, right, to make sure that engage and reduce the vibrations. Yeah. Not only that, you have different type of clutch plate. You can see that this is A is, you can have a clutch plate with the torsion damper, and B is a flexible clutch plate for passenger. You can see the like a linkage kind of thing. You can see in this arrangement. Yeah, you can see, right, this nice linkage things. Then you have a rigid. Okay, here is flexible. So, here is you have a rigid clutch plate, mostly for a passenger application. Then you have a clutch plate with the torsion dampers for commercial applications. Okay. And interestingly, nowadays, because of the heavy vehicles, they use the ceramic base. You can see this is the earlier, these are friction material. Whatever you see, these are friction material, mostly composite material. Okay. Whereas, the moment you go for a clutch plate, this is metallic means ceramic with the metal or ceramic metal composites. Okay. Metal matrix composites also there, or ceramic based metal matrix composite also there. Okay. So, the advantage is, if you use ceramic type, you can operate for a higher temperature applications, because the entire thing is operation happening due to the friction, which is the heat. Yeah, the temperature is also very crucial. So, you can see friction lining material. Okay. So, as I said, every operation, entire operation has to be done through friction lining material. So, similar to brake lining or friction lining, both are same. So, you need to have unique properties. Okay. Let me ask one more question. Would you expect the friction lining is different for a brake and clutch, or you can have same? Remember, in clutch operation, only during the clutch operation the friction line is coming to the picture. Okay, what will be the duration? Only few seconds, right? Engage and disengage, right? Maybe 2 seconds or 3 seconds. Only that time you need to use the friction lining. Okay, whereas for a brake you have to stop the entire vehicle. Okay, of course braking time, you know, it varies, single stop, repeated braking and other things also. So so you should have a high coefficient of friction, that's very critical for any operation in the clutch. Then you have to have a coefficient of friction should remain constant over the temperature range, so that you will get the required friction aspect. Then you should have a good thermal conductivity. Whatever the heat generated in the friction lining must be dissipated, otherwise what do you expect? What is the problem? You will have a hot spots, right? The moment you have a hot spot, the fading will happen. When the fading happen, then you cannot able to hold it. So instead of that holding, you will have a slip. Okay, you should not you should avoid the slip aspect. Okay, it should remain unaffected by environment. Obviously, whether the weather condition, either moist condition or a rainy season, winter season, hot weather, hot and humid, or cold weather, by any given temperature environment condition, it should remain unaffected. It should have a high resistance to the abrasive and adhesive wear. Okay, when you talk about the wear, has to be it should be less wear or wear resistant. Okay, so the friction is important. You need to have higher friction, but wear will be smaller. If you start wearing more, then you cannot perform. So obviously, if you want to have a wear resistant, what do you expect? Material would be more harder with the high hardness. So now you know that why the people are using ceramic and metallic or metal matrix. It should give a good resilience to provide a good distribution of pressure at the contact surfaces. Obviously, you cannot have a different pressure distribution, right? So if I want to hold together my two hands, what do you expect? You should have proper contact, right? If one place good contact, other place not good contact, what do you expect? Slip will occur. So you have to make sure that it should give a good distribution of pressure. Okay, such a way that the contact should be uniform. Yeah. Okay, and this is a very important thing. So friction lining material for coefficient of friction, we are going to use this table for design and design of a clutch system. You can see that you have a woven based asbestos with the cast iron included. Friction, the clutch can be operated dry condition and lubricated condition. You might think that what is this? How is lubricate condition is useful? You want to increase the friction, right? But if you moment you dip the clutch into the oil, what happened to your friction? Will decrease, right? So why do you need a oil operated clutch? That's a question. Okay, just think about that. So you can see that the woven asbestos is not useful anymore. Asbestos removed, okay, they are completely obsolete due to carcinogenic reason. Okay, now people use bronze sintered cast iron. Look at the pressure, what is going to be developed. The friction is vary from 0.1 to 0.4, and dynamic friction. It's all dynamic friction for the dry condition. This is for dry condition. This is for the oil condition. Pressure can be very high. You can go up to, right? Can we say 1 megapascal to 2 megapascal, right? That high pressure you can have. The temperature also is advantageous. You can operate at very high temperature. That's for bronze sintered metal, and this bronze sintered metal steel, which again low coefficient of friction compared to the cast iron, but for oil conditions same, the pressure is lesser compared to bronze sintered metal cast iron, and maximum temperature can have a 260 degrees Celsius. Yeah. So, the clutch design factor, you have to consider so many aspects. What is the purpose? Proper type of clutch, right? Suitable friction material, how much torque you are going to transfer. Okay. Again depends upon the type of vehicle, whether it is a two-wheeler or four-wheeler. Again, when you have a four-wheeler, it is a passenger car or SUV type of on-road vehicle or off-road vehicle. There are so many classification there. Based on that, you have to decide what is the torque capacity. Engagement disengagement should be smooth without shock and jerk, it is quite obvious, and should be as low as weight possible. Obviously, you need to reduce the specific fuel consumption. So, the weight has to be minimum. And the provision for taking compensating wear of rubbing surfaces, obviously they rub, right. So, relative motion, they contact and try to engage both during the operation, either disengagement engagement. So, the wear has to be smaller and such a way that it should be adjusted also, right. Provision of carrying away the heat generated at the rubbing surface is nothing but high thermal conductivity, thermal conductivity, so that the heat dissipation will be done in proper way. Okay. I think I will stop here the clutch design analysis. I will discuss more detail in tomorrow lectures. Thank you.